Today we are kicking off the show with the lab coat legends. Adam Sherwinski has brought me to the weather garden.
Yeah, you know what? We're out here in the weather garden. Last time we were out here, it was cold.
Yes, it was freezing because we froze a pair of pants and a shirt.
Yeah, now we're doing the opposite.
Today
we're outside.
it's
a little
how
hot.
warm?
It's like it's in the 80s
warm.
out here, I would say, or close to 80s and the 70s. It's not actually that bad of the day, considering we've had those triple-digit heat index values earlier on. Not so much now. I will say that this lab coat legends, you actually probably are going to need these.
I was going to say, today I am going to need my goggles, so we are going to put them on. But first, before we get to the experiment, can you tell us a little bit about fireworks and what causes the beautiful, bright colors that we see in the night sky?
Well, it's kind of just chemistry, really. I mean, the different kind of materials that they're using for those fireworks. You know, we always think of fireworks, you light them, you throw them, they go boom, that's it. There's nothing else to it, just some gunpowder and you call it a day, right? There's actually some science. Different materials within those fireworks are really what makes it up. And you can kind of see there, the firework color ingredients kind of color-coded. You see that kind of orange color. Well, that's calcium. You see green, that's barium. And I also use the letters in there, too, that you will find on the periodic table. Know your periodic table, folks. Not by heart, but as much as you can. And know some of the basic ones. Sodium, Na. Then you got strontium, and then you add some of those strontium mixed with a little bit of calcium, and that's how you get your different colors there. Sorry, copper, not calcium, or Ca, not Cu. It's hard to see from out here. And then you've got the different colors mixed together to get those other combinations there, too. So that's how you get their color coordinated. It's not just light them off and see what happens. There is some science involved by those firework makers involved there. So kind of cool to see, right?
And I feel like now you can impress your friends, right? You can see a green firework and be like, huh, I know that
was using barium to make that
color.
color here. Hey, I've also got the colors if you want to see it real quick, just the different colors that they have. I think it's on my graphic there again. There we go. You can kind of color coordinate there. So there you go. That way, if the letters and the periodic table wasn't enough for you, you can kind of just take it back and go from that one step backwards and kind of go, okay, now I can put the colors to what the words are.
Yeah, and I like the way you've done that because the barium and you saw the periodic table colors, and now you can just see the copper, the magnesium. White ones are magnesium. I feel like most of them are magnesium because I feel like a lot of them are white. But today,
or like a yellowish white, yeah.
Yes.
We're gonna do our own explosion that has nothing to do with any of the physics of fireworks. Look at that. We threw you what is that? A red herring? Is that what they call it there?
I was gonna say, although that was really interesting.
Yeah.
So that was the science part of today's Lab Coat Legends, and then now we're gonna do a fun science experiment that is kind of a firework-esque thing. I've actually heard about this, and this is sort of that urban legend, but I've never actually done it.
Uh-oh, you already know what it is.
I was going to say, you see the 2-liter sitting here, and he's got the Mentos in his hand. So we are going to put some Mentos in Diet Coke and see what happens. Now I understand why we have come out to the weather garden for this particular
It's already opened. I already opened it, so it's not as volatile.
Okay.
All right, you ready?
Are we putting it on the table? Am I holding it?
I would say put it on the table. You might want to move your cards, though, I will say.
We're going to put it on the table.
All right.
And then step back.
All right.
All right, here we go. Oh, wow.
And that was just two. And that was just two of them.
I was going to say, and I can tell, he's got them in his hand and he's itching to do more. You told me to move my cards, but then we left some Mentos. Hold on, I kind of want to put one in.
Yeah,
and see.
Let's see how much is left. You know, there's probably not as much.
See if there's any more power in it. Oh, here it comes, here it comes.
See, I should have done it where I have a sleeve of them and just go from there, but
drop the whole
thing. Yeah, I couldn't get that to work. But try it the whole sleeve. Try one or two, and try different pops too. I've tried it before with Coke. It doesn't work as well like regular Coke. Try it with Sprite. Try it with maybe some
ginger ale,
different ones, because I've heard that this is the best way to do it, is to do it with Diet Coke. No one can explain why Diet Coke and Mentos 100% works together that way. And now they can't explain why it happens, but not why it happens so rapidly compared to other stuff.
Right.
And because this is not a chemical reaction. This is a physical reaction. Basically, remember when we did our raisins a while back?
I was just going to say, this reminds me of the dancing raisins.
It's very similar to the dancing raisins, and because of the surface and the way that the Mentos are, try different kinds of Mentos too if you want to try and experiment a little bit. Just don't do this at the grill out, okay? Leave those sodas alone, because no one's going to be happy when you do that. I think I gave a lot of people bad ideas. Anyway, But what you want to do is, it's really just the texture of that. Remember when those raisins, they had the different spots where the carbonation grabs on and then it starts to dance?
If you missed that episode, we took some raisins and we put it in carbonated soda water, and ultimately in regular water, the raisins just sank to the bottom, but the soda water, it kind of bubbled up around it and made the raisins dance.
Same process, really, and it's you're getting that gas, because whenever you take pop, you can get that gas trying to go out. It tries to switch over from, like, it just wants to escape, and so that's the whole thing. It's a physical process, not a chemical process. Even though it looks like a chemical process, it's a physical process. Those bubbles are trying to latch on and then go. So
right, exactly. And so ultimately, like we always talk about, there are so many different ways to do these experiments, and it's really fun to try with different sodas, different flavors of Mentos, and see if you have bigger reactions. You can even measure how high the soda jumps up, but I would say make sure that you're doing it in an area where you have plenty of space and don't mind getting some stuff a little bit sticky. Well,
I took a Mentos, sorry.
I was going to say, now he's chewing. Thank you so much for being here and for teaching us this experiment and for showing us what the colors of fireworks are. That is really fascinating. Thank you for always doing Lab Coat Legends, Adam. If you have a question for Adam, you can email him at asherwinski@wcia.com, and you can write in your questions, or if you have a science experiment that you want to recommend, you can also find us both on social media.